So for this problem here, we're going to want to write the equation of the line, use that line to find another answer, and then also graph the line. The very first thing that I would recommend doing when you're looking at a story problem is to decide the labels on the coordinates x, comma, y. After that, it'll go a little bit easier. So as I'm reading through this, I ultimately want to think about what depends on what. So the Sugar Sweet Company is going to transport its sugar to market. It will cost $4,500 to rent trucks, and it will cost an additional $250 for each ton of sugar transported. Let C represent the total cost in dollars, and S represent the amount of sugar in tons. So far we know the X and Y is either C or S. Write an equation relating C and S, then use the equation to find the total cost to transport 12 tons of sugar. Okay, so if there's two things going on, the C and the S, and one of them is the cost of the sugar, the cost to transport the sugar, and the other one is the number of tons transported. So which sentence makes more sense? Does it make more sense to say that the number of tons transported depends on the cost, or the cost to transport depends on how many tons you ship?
How many tons you ship?
Yeah. So I'm going to say the cost depends on the tons transported. Okay, the more tons you transport, the more money you're going to pay. And if you can write yourself a sentence that has something depends on something, whatever comes first is always your y coordinate, and whatever comes after the word depends on is your x coordinate. So putting that in for my x comma y, in other words, my x is going to be the tons of sugar, and the y is going to be the cost. Okay, so then just putting on some extra labels here. This is tons and the cost is money. So my points are going to be tons, comma, money. This is going to go a long way to figuring out my M and B that I need to write the equation. So keeping in mind that the B is your y-intercept. Okay, if it's a y-intercept, that means where the graph starts on the y-axis. And so if that's where it starts on the y-axis, okay, then what we have here is it's your beginning y, but the y in this is the money, so it's the beginning cost. So if it's the beginning cost, let's look back up here. It says that it's going to cost $4,500 just to rent the trucks. And then after that, it's going to cost so much per ton. So the starting amount of money is going to end up being $4,500. So we now know the B value. Now we've got to figure out the M. And you know that slope is rise over run. Now think about labels. If we have some labels, rise is about your y's and run is about your x's. So it's going to be cost over tons of sugar. Okay, so I'm going to have cost over tons of sugar, which is the same thing as money over tons. That helps me when I'm reading through this. I'm looking for some number up here that is money per ton. So when I go to read through, it says an additional $250 for each ton of sugar. In other words, $250 per 1 ton. Okay, then 250 over 1 is 250. Okay, so the labels have gone a long way for me to figure out what the number on the end is because it's the starting cost. And this number here is cost over tons. And now I know which number went where. Okay, then let's use the variables that they ask us to. It says that the tons of sugar, we want to use the letter S, and cost, we want to use the letter C. So instead of a Y, I'm going to put a C, and instead of an X, that's going to be tons of sugar, and they're using the variable S. We know that the slope is 250. Okay, so I'm going to put in 250 here, and I know the y-intercept is 4,500. I have the equation now, so I can answer that question, find the total to transport 12 tons. So the cost to transport 12 tons, that means I'm going to replace, and if you're not sure where to replace it, again, go back to our labels. Tons is the X. And so when it says 12 tons, we're going to replace the X with 12. Now if I go ahead and simplify here, the cost is going to equal 250 times 12 is 3,000 plus 4,500, and I end up with $7,500 is the cost to transport. Okay, and then it continues on in the next topic that you want to graph. And so you've got to create the equation to start off with, although I think that it's easier to come up with the equation when the graph is already set up for you. Because if you remember, our very first step in this one was to decide that our points were tons, comma, cost. But when you have a picture of a graph already set up, it says that S is on the x-axis and that C was on the y-axis. And so that tells me that our points are tons, comma, money. And then you can go after the starting amount, the starting cost, and then the rise over run cost per ton. I think it goes a little faster. Okay, but once we have that, remember you're beginning at 4,500. So on the y-axis, this is my beginning amount. So I'm going to come over here, move that over just a little bit. So at 4,500, let me just do that. Okay, so we're at 4,500, and then rise over run, so I can go up 250 over 1, and that'll be my new point. Something though, because you're working on a graph that already has what you're counting by. So what you might want to do instead is if I substitute 1, then I end up getting out 4,750, and there's that, there's gonna be, let me just write this point here really quick. So that's 1, comma, 4,750. Okay, and then I'm going to draw this line, and we have it graphed. But there's a feature on ALEKS where you can click a button, and then it lets you type in the point and then hit plot, and then it plots it for you. And then you won't have to stick to the numbers they have down here. But let's say that the first number that they had was 2, well then I'd have to go up 250 over 1, up 250 over 1 if you want to use their grid.